Hello and welcome to Sphero Bots. I am Chris Beckwith and I am an MLTI ambassador. And with me is my colleague, Jeff Ireland. He's making sure I stay on track and keep me in line. And I'm pretty excited to talk about the two different robots that were included with the Sphero robotics and programming computer science carts. And so if I share this presentation. Are we on full screen with that? All right. Okay.
Welcome to another Lunch and Learn. If you've been here before, we're glad to have you back. If this is new to you, we are glad that you have joined us. So if you have missed some Lunch and Learns in the past, you can go ahead and the same place that you got the link for this also has all of the recordings from our previous topics. I just want to mention a couple of opportunities and a couple of reminders before you go ahead and get started on your topic for today. First of all, we have a virtual and in-person student conference. The in-person student conference is in May, and you still have time to register for that. The virtual conference, we will be hosting most schools on March 7th, but it can be done at your own pace and your own time. So if you are still interested in that asynchronous learning environment, there's lots of great resources. Just reach out to me, donna.netzer@maine.gov. I also send out a newsletter twice a month. I try to do it every 2 weeks. It has 3 resources or 2 resources and an opportunity. There's lots of different stuff in there, and I just added an AI spotlight. So make sure that you are looking for that. We have a couple of opportunities coming from the consortium on digital citizenship and a choose your own adventure professional development. So Tim Reynolds will be sending out some emails on that fairly soon. And as you are thinking about next year, I know sometimes it's hard to think that far ahead. Just remember that our team, the MLTI team, the Learning Through Technology team, provides free professional development, and we can tailor it to what your school or your district needs. So don't hesitate to reach out as you are planning ahead. Thank you and have a wonderful session.
Thank you, Donna. So your robotics kits came with 2 flavors of robots. So I would like to talk about the Indie first. The Indie can give the impression of something that's only applicable to really younger grades. And I can see where that comes from, but the more I've used them, the more I have found that there could be applications all the way up through high school. My background is in physical science and teaching physics, so when I saw these, I immediately thought of a lot of physical science applications, and I'll talk about those in a couple of minutes. So to differentiate these robots from the Sphero bolts, and I also want to clarify, a lot of people use Sphero, the word Sphero, when they're talking about the round spherical robots. They call those Spheros. Sphero is the company that makes a lot of different robots, from these Indy cars to the bolts, which are spherical, to Star Wars robot-shaped robots. So robot-shaped robots, that's a good phrase. And so this is the Sphero Indy, and its motion is just simple linear motion. It goes in straight lines. It can turn at angles. It has what we call screenless programming. So the kids don't need any device at all to program it. It comes with these little rubber colored mats, and you put the tiles down on the floor. Each color triggers a certain response from the Indie bot, and we'll have it do certain things. So a great starting activity right from the beginning is, don't tell the kids how they work. Just give them the kits, give them a bot and the set of tiles, and let them figure out how they work and what does what. Have them keep notes for what each tile does. And in addition to the movement, which tiles make it move in which ways, have them pay attention to the different sounds that the bot makes each time it identifies a specific color, and the LEDs, the color changes that the bot goes through when it recognizes a different color. There's a lot of different feedback that the bot gives you when it recognizes a color, and that's something that kids could be looking and listening for. The basics of it, the basic simple motion would give you a lot of applications for any class kind of across the content area. Like I was saying, with even in high school physics classes, a lot of times it's desirable to have an object that moves at a constant speed. And these are a perfect example of that. They'll move at a constant speed. The kids can take measurements, calculate what its speed is, measuring the distance and time. They could add mass to the top of them. They could put some extra things on top of the vehicles to increase their mass to see how that changes their acceleration. And they could calculate the acceleration by calculating the change in velocity, and then maybe calculate the force that the motor is putting out. So there's a lot of different advanced calculations and measurements that you could do here. Even though it is on the surface a simple device, it really is a desirable physical science apparatus. Back to elementary grades, it's really good problem solving, just figuring out how to get them from one place to another using the tiles. And the tiles are limited in a smart way also. If you've got a tile that makes it turn 90 degrees to the right, and you want to make it go in a loop, you would think, well, I need 4 of those tiles. But each kit for each robot only comes with 3 of those tiles. So you can tell the kids, without borrowing from another group, how could you make this go in a continuous loop without borrowing with just the tiles that you have? And that is a big challenge. With my middle school students, not a lot of them figure that out. And there are different ways to do it. So then you say, okay, you got it going in a continuous loop now, without interference. What's the least number of tiles you could do that with? Because I bet you could remove some of these and do it in a more efficient way. And then you're tying in, even though you're not really coding here, you can tie it into coding where there is value in writing a computer program using fewer lines of code. The less lines of code you use, the more efficient your app is, the less space it takes up for people downloading it and on their devices. So if we can do the same task in less lines of code, or in this case, fewer color tiles, then that is desirable and a good challenge for them. If you in the resource section, there are several links there that will give you some activity examples for using the Indie bots. So one method is using them for digital storytelling. Depending on what is being taught, the bots could travel from one location to another and demonstrating a particular sequence, demonstrating different events, visiting different events that happened in a story they're reading, or showing the order that things might happen in a scientific process or historical process. So there are different applications. They're getting some good problem solving, but this does not have to be a standalone tech activity. This is something that they could do in a math class, for example. They could bring these in and calculate the angle, measure the angles that they're turning, and figure out, be given a challenge. You have to create a polygon with a certain number of sides, and how can you do that with the tiles that you're given? So across the content area, and using the um, mobile app unlocks a lot of additional features. Just on a laptop uh, or a Chromebook, you have kind of limited. Well, I guess I don't want to say that. Mobile, it would have to be. I think the Chromebook app counts as mobile. Other laptops don't, because it's only a mobile app. But when you go from screenless to screen programming on a mobile device, you unlock a lot of features like the ability to reprogram the tiles. So instead of a particular color making it turn at a specific angle and direction, uh, you can reprogram that to do something different. You can add some colors to its ability. So in addition to the tiles that it has, you could print out some new colors and assign new tasks to those new colors. You can, it has a lot of pre-built, pre-installed sound effects that it does whenever it hits the existing tiles, but you can change those. And when the kids, after they're used to the standard sounds, when they realize that they can customize and get some new sounds and songs out of it, and when they realize that different things, different colors can trigger specific musical notes, all of a sudden you've got a really cool way to tie tech and the arts together with a STEAM activity where the kids can make it play a certain song by having it pass over specific colors that play a certain note at a certain time. And then imagine combining that with the other indies in the room where they're all kind of giving one big coordinated symphony, playing specific notes to produce a specific tune. So lots of potential here for what looks like on the surface a really simple bot, but that's it's a great tool across the board. So I want to make sure I mention one thing I learned from experience that I wished I knew at the beginning. What I call tile management is that the indies they kind of come in their own little charging case, and then there's eight bots per case, and then you've got these 8 little suitcases that have all the color tiles with them. And so if a kid or a group of kids, a group takes a car and the suitcase with the tiles, and they go off and work on their own, that's great. But at the end of class, you need to make sure that they come back with everything that they left with. And if they're sitting next to other people and all the groups have their tiles scattered all over the floor, when they gather them up, they're not super careful about making sure that they have the right number of each tile. Now it tells you right on the lid of the little suitcase, it tells you how many of each color you should have, but they don't seem to pay attention to that, and they just scoop up whatever's closest to them and put them in. So the next class to come along gets a mismatched kit of tiles, and they say, oh, I don't have enough of this, and I've got too many of this. So then we have to take the first 10 minutes of the next class sorting those out. So make sure you give yourself enough time at the end of each class and have them do a tile count with their own tiles. Don't let them turn those kits in until they've checked them and they've got the right number of each tile in each kit. They also come with little stickers that kids are dying to stick all over them and personalize. So if you don't want that to happen, you may want to grab those sticker kits out of the activity cards before the kids see them. Or maybe it could be a reward for those kids that figure out how to do an endless loop with the least amount of tiles. And the tiles, I found that depending on the custodial competence of your building, so I will sweep my floors sometimes before I put these mats down, before I let the kids start putting the tiles down, because they are like a floppy rubber mat. And if the floor is dusty or hairy or whatever, that when these mats come back, they're kind of frightening. So putting them down, it's nice to put them down on a clean floor so that the next class doesn't have to pick things off of them. and the more sophisticated cousin that came in the kit is the Sphero Bolt, and that is a spherical robot. And these are amazing devices. It's highly maneuverable. These, unlike the linear motion, these can be programmed to go in curved paths. You can control the speed here. You have just a much greater degree of control over these than with the indies. They also have real-time sensor data in them, several sensors, so that they know when they're falling, they know when they stop falling, they know when and how they're accelerating, and they give this data to you in real time. So again, for physical science classes or math classes where you want to collect data and analyze graphs, it provides it right there, real time on the screens. Kids just click a tab in the app and it shows the graphing data, and they can hold it in their hand and tip it around and activate the gyroscope and see the data changing right on the screen while they're moving it. So if the challenge was, for example, in a physical science class to program the bolt so that it moves with so that it creates an acceleration versus time graph showing positive acceleration. If that's a class, it maybe as advanced as high school physics, but this would be a great tool for that because it would produce that. They program the motion and it will produce the graphs. Multiple LEDs on here. My favorite is the LED matrix, and that could be that could be an activity by itself. If this was just a ball with that matrix on it, there would be so much learning that could happen right there, because right from the start, this takes the idea of the coordinate plane in math class with an XY axis and brings it into the physical world so that they can plot points on there. When they plot these points, they can do it using like XY coordinates, and they can create not only any image, they create an image there using those pixels. Looks like a 8x8 matrix there. Not they can create an image, but that can also be the first frame of an animation. So they're all familiar with how animations work frame by frame, so they can create their own animation on there and have that playing to demonstrate what they're learning in their classes. One project that I was involved in had the Bolt traveling to different locations in Maine as part of the Farm and Sea to School program, and it would travel to a location in Maine, maybe a specific farmer's market or a fisherman's market. And when it got there on the main map, it's with a big main map on the ground, the bolt is traveling around the main map. And when it got to the specific location for that market, it would show a picture on the matrix of what it was buying there. And so if it went to the fish market, it could show a picture of a fish, and then it could travel to the next location and it could show a picture of some potatoes. And so that the matrix can represent not just pictures of what they're learning in class, but tell it with a story, tell it with an animated story. And it doesn't take too much imagination to realize how you could just, even without any movement at all, have this bolt sitting on your desk with the students, and they create an animation that represents a science principle or something in history that they're learning about, something that happened in a story they're reading. They can represent anything they want on there graphically and with the animation. So that's kind of exciting. They can do this using blocks or JavaScript. So depending on the level that your students are comfortable with, most of them are familiar with blocks by the time they get to middle school. But I found the Bolt is a great opportunity to introduce kids to some JavaScript, and starting with simple movement and starting with the matrix, because When you're using blocks, you're just drawing on the screen to create the pattern that you want on the matrix. When you're using JavaScript, you're telling it, plot this point at this XY coordinate. So it's not complicated. I gave a link to the JavaScript Bolt wiki in the resources, and they tell you right there, for, let's say, for simple movement, here's the block you would use, but here's the JavaScript code that you would use. And the kids are able to do that. They're able to type in that code and create that program and get it to do what they want. And it's a really great first step into text coding for them to actually be controlling a real world object with actual text code. I've said for the age range here, I have said most appropriate for grades 6 through 12 because of the higher level of features that it has with the sensor data and the ability for advanced programming. But you could go 3 through 5 as well. They can do, if anyone that can do block coding could make this move and could make pictures on the matrix. So certainly applicable there. I don't know that I would go too much younger than 3, but it depends on the students, I guess. Other features that this has is it in addition to the sensors, it can broadcast messages to the other bolts. So you can program one bolt to send out a signal that another bolt receives, and when the second bolt receives that signal, it can be programmed to respond in a particular way. And that, you can imagine, opens up a whole new realm of collaboration and interactivity between the groups that are working in the room with these. So one bolt rolls up to, like a chain reaction kind of thing. One bolt rolls up to another one, gives the broadcast a signal, maybe shows a picture. I had kids program a wedding between 2 bolts. And so one rolled up to another one and showed a picture of a diamond ring, and the other one showed on their matrix, it said yes. And so then they switched, and when one rolled away, the other one could follow it because it can broadcast a signal to follow me. And anytime one shows a symbol, it can elicit a response from the other one by broadcasting these messages back and forth. That can all be done with block code or JavaScript as well. So enormous potential there for classroom collaboration. My tips for working with the bolt, I know some classrooms set up kind of an arena with pool noodles so that they don't get away from the play area, because it's easier for them to roll under desks and under tables. And that's great if you have them, but it's not necessary. Again, clean floors are nice, but you can, just kids need to pay attention. I've had kids try to walk out of the room and like, where's your bolt? I don't know. It went under a desk and I couldn't find it. Well, I bet you can find it if you keep looking. So you just make sure you get them all back in the box before the kids walk out of the room. I want to mention, I'll get back to pairing, but protecting them, they all came with these silicone shells to put on them for protection. I think I forget what they call it, like a turbo sleeve or something, but it gives it more grip, and it gives it better traction. If you think about a smooth plastic shell trying to spin against a smooth tile floor, it's not going to have the traction that it would have if it had a rubberized kind of silicone shell on it. So it does give it better traction, and protects it from getting scratched. The only downside to using the shells is it obscures the matrix quite a bit. You really can't see clearly what's on the matrix. You can see vaguely the colors that are appearing there, but you wouldn't be able to, you'd have a hard time kind of reading anything that was on there. So if I'm doing something with just the matrix, where the matrix is exclusively important, I would take that. I would open up the shell and make sure that the matrix was visible. I use the shell as a little cradle or a nest for when we're just programming the matrix. Kids can set it on their desk, kind of sitting in the shell, but the shell is peeled back so that the matrix is visible. That helps keep it from rolling off the table. I tell them if it's going to be on the floor, the sleeve needs to be on, because they're just too great looking to be all scratched up. Once that plastic shell gets all scratched up, it's never going to look crystal clear like that. And so I try to protect them with the shell as much as possible. But the shells, like the rubber mats of the indies, the shells are very good at picking up whatever dirt and hair you've got on the floor. So pairing these bolts is a challenge. You don't have to worry about pairing the indies until you get with the doing the more advanced things with the mobile app, and then that's fairly simple process because they are named. Pairing the bolts is a little more difficult because it's a brilliantly designed robot, but for these particular models, at least the models at my school had, if you're whoever designed these thought it would be a good idea to print the name of the robot on each one in black ink in a very small font against a black background. So you absolutely cannot read it with the silicone sleeve on, and even with the sleeve off, unless you know where to look, it can be very difficult to find the name. So I say there's two ways to pair these. There's a hard way and a harder way. So the worst way, I think, would be looking at each one and finding the name, and then going to the pair list and picking that out from the list of names there. That's not fun, and it's not particularly easy. Supposedly, and I don't see this happen all the time where I would recommend it more, but when the bolts are sitting in their charging cradles and you pick it up out of the cradle, if everything's plugged in and turned on, it should broadcast the name of the bolt. I don't want to say broadcast, that means a different thing, but it should display the name of the bolt on the LED matrix. So if they take that and they read that and they go back and they pick that from the list, that's great. That could work. But otherwise, they use a method they call like the Harry Potter method with the sorting hats. And basically that method involves when they're in the app, the Sphero EDU app, you click on the little Sphero robot icon in the upper right, and it shows the list of all of the available bots to pair with. And you don't know which one you're going to get. So I tell the kids, just click on the first one on the list and pair with it. And when it says you're paired, go down to there's another panel they can open up where they can change the main color of their bot. So once it says they're paired with a mystery bot, I have them go down and pick a color that no one else is using. So if someone makes theirs lime green, they can go over to the box of all the bolts and say, oh, look at the green one, that's mine. They can pull that out. And they like that. They sometimes you'll do that with a partner. It's usually we partner up with these. We've got someone programming and someone spotting and chasing. So someone can be up there and they're like, what color did you make it? I made it light blue. So they change the color and they're like, now I'm making it flicker between blue and red. Okay, I see it. And they grab it. So they have fun with that. And it helps their bolt stand out from the crowd. That can be the pairing of them at the beginning of class can be probably the biggest hassle that you'll get with the bolts is just getting those paired up. Sometimes they just have a difficult time pairing them. They just won't pair with any of them. Restart your computer. There's a way to kind of reset the charging cradles and the bolts and in the bolt charging case themselves. They've got a little button down there on the charging cradle. So if you hold down that button when you take the bolt out, it's supposed to kind of do a little reset there, and then you can put it back in to reactivate it. So the different things to try, but eventually you'll get everybody paired up. And and then you just want to make sure that they are resisting the, like I said, they're designed to be tough. They're designed to drop and fall. There are programs that specifically are meant for that, for to do something when it falls. But you don't want kids like tossing these around and trying to juggle them, especially if they don't have the silicone sleeves on, because there's only so much they can take, and if they hit a hard floor without that sleeve on, that's going to end your activity pretty quick. So the resources that I would like to share, the first three are indie specific, and the third one they are talking about how you can go farther using the mobile app. The second one talks about several example uh, activities just the indie right out of the box. And the first one is just kind of an introduction to what the indie can do. With the Bolt resources, there's the JavaScript wiki, and I put a footnote there just saying that links to a shared Google Doc that Sphero created. So you may need to make sure. I've done workshops at schools where they would try to go there and that was blocked because their school blocks Google Sites. That maybe it was whatever it was something that may be often blocked. I don't know if it was a site or a shared doc, but it has been blocked frequently to the point where Sphero even says on their website, you might want to make sure that your district allows access to this URL. And then there's three websites there or videos talking about the different features in increasing complexity. The last two might be for more advanced middle school or high school students. You can see an example here in this screenshot. It's comparing movement commands with the block codes versus the JavaScript codes. And the kids can do it. They can look at that and they can see those three numbers that you're going to type into the JavaScript coding correspond to the role, the speed, and the time in the block codes. I do want to mention that one of the things that seems to make the Bolt unique compared to other robots is that typically robots that I've had experience with, a movement command would involve to move at a specific angle for a certain amount of time at a and maybe maybe a speed and a distance. You've got a lot of different variables there, and the big difference here is like with other robots, like 0 degrees might be straight ahead, and 90 degrees might be a 90-degree turn to the right with respect to its original heading. But that doesn't apply with the bolts. With the bolts, they are compass headings right from the beginning. So the first thing you've got to do when you put a bolt on the ground is you have to orient it. And that's done by clicking on one of the little icons in the top right corner of the app. It's the same place where you can change the color of the LEDs. There's a little circle with a dot in it around the perimeter that says aim. And you grab that little perimeter dot, and as you circle that around that outer circle, you will watch your bolt, and there's a single blue light. When you're in aiming mode, there's a single blue light that goes around. That blue light is the tail light. And so if I want 0 degrees to be straight ahead away from me, then I'm going to point the tail light towards me. So when it goes at 0 degrees, that'll be the opposite direction that tail light was pointing, and it'll go away from me. And for the rest of the program, that's what 0 degrees will be. And if I say turn 90 degrees or roll at a heading of 90 degrees, it's not saying turn, it says roll 90 degrees. So it's not a turn 90 degrees, it's roll at the 90-degree heading. So it will turn 90 degrees to the right from that original zero setting that I calibrated. And if I say 180, it's going to go back towards me, and that'll always be back towards me unless I change that original calibration. And you pretty much have to calibrate it every time you put it on the ground, so it knows what are you calling straight ahead. And that's something kids have to get used to. It's not going to go where they tell it to go, especially if you set up an obstacle course and it has to navigate a specific course here and end up at a specific location. It will not get there if they have not calibrated that distance and aimed it first. So that's something for them to get used to, that it's not turn 90 degrees. It's not reverse your direction and go 180 degrees. Those are compass headings that it will go to based on your original calibration. So I hope that makes sense. And this is the part where you would all shower me with questions about the bolts and the Indy bots, but you are going to have our contact information. I know that Donna will make sure that you have that so that you can contact us, Chris Beckwith and Jeff Ireland, about anything that you saw in this presentation here. And we'll be happy to work with you and answer your questions, and meet up virtually if need be to get these literally rolling, because you've got them sitting in the cases ready to go with students, and there's enormous potential here. So I'm excited to share what I know about them, and I'm excited to see what you guys all do with them. So thank you for your time and attention with this video.